Yeah. So coming back to GRB progenitors, the most important clue has been obtained from uh, connection of supernovae with GRBs. The very first connection observationally seen for GRB with supernovae was back in 1998, where supernova type 1BC called 1998 VW was observationally proven both spatially and temporally to be connected with GRB 980425. And this was the very first case which was established and was a formed confirmation, spectroscopic confirmation of the GRB with supernova. Later, many other cases have been also seen. For example, around same time, supernova GRB called 1998-03-28, which showed a red bump in the late time of the light curve, and the supernova template 1998 VW was matching well with this red bump. Spectroscopic confirmation also showed that this was another piece of evidence of the GRB or the connection of supernova. Here is another case of GRB 03-03-29, which is a very bright optical afterglow candidate, and even in the picture you see the 2.2 meter ESA telescope data, and it was soon it faded away from the picture, and this is a VLT 8.1 meter data which shows that the object was faint enough, and later at other frequencies it was observed by 2.2 meter with BOOSCA instrument, and which shows that it was fading. But the spectroscopic observations indicate that at all those epochs, this supernova evolution was happening from beginning to the end, and later the spectroscopic observations taken at later epochs were well matching with the template observations of 1998 VW. So this was another piece of evidence that type 1BC supernovae have connections with GRB. Spectral modelings of this observations of spectrum of this afterglows have also indicated that many cases, and so far nearly half a dozen cases have been seen where spectroscopic confirmation have been established with GRB. But some exceptions are also there in two cases back in 2006, 060505 and 060614. Even after being very nearby, these GRBs do not show any connections with supernovae. No evidences were seen to a very deep limits for the connection of supernovae with these GRBs. So these are exceptions that not all the long duration GRBs are always connected with supernovae. Many theories have been proposed regarding how massive stars can evolve and what kind of effects they can give rise to, and probably GRBs, they are also part of evolution of massive star, and in this connection, rapid rotation have been a very important clue about formation of the GRB from a collapse of a massive star. And the rapid rotation is very important both in pulsar and in magnetized scenario, where both magnitude and energy limits have been predicted theoretically quite well, and these indicate that in the evolution of massive stars, rotation plays a very crucial role towards understanding of GRBs. Computer simulation of very high energy, very massive stars also showed that high angular momentum in the core is very important for producing relativistic bipolar jets from very massive stars. And the jet formation have been studied, and it has also been established that hydrogen stripped supernovae might be connected with GRBs, but rotation is important in these cases. Several progenitor models have been produced for the progenitions of long duration GRBs, where tidal sign-up of helium stars and close binary or maybe mass transfer from a binary with a low mass star companion, or merger of a helium core, or maybe neutron star black hole, or some systems where it has been proposed that chemically homogeneous evolution scenario uh, where a star is gradually transformed into a Wolf-Rayet star on the main sequence even without mass loss, or with mass loss also in some cases. It has been seen that from these Wolf-Rayet stars this kind of GRB situation explosion can be produced. Here, the simulation graph in the green lines have been shown in two cases where relatively high metallicity and relatively low metallicity. And these metallicity situations have indicated that once the metallicity is low, chances for a massive star to produce a GRB have been higher than that of a higher metallicity. So for this indicate that probably population 3 stars are the stars which have been very massive and without any contamination for further metal enrichments are very much responsible for this production of the GRB. Another important piece of information which is coming from towards our understanding of GRBs are the GRB host galaxies itself. And in this picture, you can see the host galaxies which have been observed from HST, Hubble Space Telescope. And in these figures, it is clear that these host galaxies are really faint, they are diffuse, they are either compact or irregular. And it is also clear that in these host galaxies, GRBs are mainly concentrated at the brightest regions of this host galaxy, which are basically the star-forming regions. So maybe they are star-forming galaxies having dense environments or something like that. GRBs, they also seems like tracing the stellar distribution, and they all suggest in favor of a collapsar model or the merger model. So possibly the host galaxy information indicate that long duration GRBs are actually coming out due to collapse of a massive star rather than a collisions binary. GRB host galaxies have given additional piece of information deciphering that how long duration GRBs are different from the short ones, and the bimodality distribution what we saw in the beginning, and accordingly the difference in possible progenitors has also been evident from the host galaxy studies. And in host galaxy studies we have seen that short duration host galaxies are first of all they have been observed only at the closer distances. Another is that they occur both in spiral and elliptical galaxies, whereas long duration GRBs have been found in irregular, mostly in compact galaxies. Another piece of information which we have got is that GRB host offsets do not trace the blue light of their host galaxies, where in the long duration GRBs are tracing the blue light content. It means they are occurring in the star forming regions, where in case of short duration they don't. Also that short duration GRBs, they release less energies and their central engines are also long-lived. They all indicate to collisions binary system. So GRB hosts are providing additional piece of information towards our understanding about the resonator systems. Save it.